We'll come back to second lesson in Unit 1. Last time we talked about root radicals. Today we're going to be looking at rational exponents. Before we start looking at the rational exponents, we're going to do a quick review of the exponent laws. Okay, so I'm going to do it on the top here. There are several rules that you need to know that we've seen before. First, we have x to the power of a times x to the power of b. Remember, when we multiply powers with the same base, what we are going to do is we're going to add the exponents together. Okay, so on the other hand, if we are dividing powers with the same base, that means we are going to subtract exponents. We could also run into power of a power, so like this. I usually refer this to having exponents back to back. So x to the power of a to the power of b. When we have power of a power, what we do is we multiply the exponents together. We could have exponent of 0. Recall that means it's always going to be 1. Okay, anything with the power of 0 is 1. And the last one is the negative exponent. So when we have negative exponent, remember we could just simply reciprocate this base. So x is the same thing as x over 1. When you see negative exponent, you simply flip the fraction, and then the negative exponent turn into a positive exponent. Okay, so that's how it works with negative exponents. So these were the 5 rules that you learned in previous years. We have 2 examples here, and let's see if we can figure out how to do them. Okay, so the first example, what I'm going to do first is I'm going to distribute these exponents, okay, into the brackets. Okay, so we have 3 squared, which is 9, and then we have a to the power of negative 4, right? That's again exponents back to back, so we multiply exponents together. B to the power of 6 times you know what, actually, since these coefficients are all 3's, okay, I'm not going to expand. I'm going to keep it as 3 squared. This one is going to be 3 to the power of negative 1, and then a to the power of 1, because it's negative 1 times negative 1. B will be power of 4, because it's negative 4 times negative 1, over 3 to the power of negative 3. We have a to the power of 6, and b to the power of positive 6. Did I say a to the 6? A to the negative 6, and b to the power of 6. Okay, now we are going to multiply the numerator. So when we multiply, we multiply the power with the same base. So that has a base 3, that has a base 3. So then we can actually multiply them together by adding the exponents. So that's going to be 3 to the power of 1. For a, same thing, we multiply them and we just add exponents. So negative 4 plus 1 is negative 3. For b, that's 6 plus 4, that's 10. Over 3 to the negative 3, b to the negative 6, and b to the power of 6. And now, because this is division of powers with same base, then we just again subtract the exponents, again according to the rules that we learned in the past. So this is going to be 1 minus negative 3, which is 4. That's negative 3 minus negative 6, so that's positive 3. And that's 10 minus 6, that's a 4. Finally, 3 to the power of 4 is 81, so your answer is 81 a cubed b to the power of 4. Okay. Number 2, this one is, I'll show you a little trick here. Because both of these exponents are the same, right? They are just n's. In that case, what we can do is we can actually multiply whatever that's inside the brackets first. Okay, you can actually multiply these two first before you worry about the exponent of n. Okay, so we can actually do that first. Okay, these two are the same thing. So now what I'm going to do is I'm going to multiply the numerators with the numerator and then denominators together. 9 times 3 is 27. 8 times 2 is 16. We have a to the power of 1 times a to the power of negative 2. So multiply them together, you get a to the negative 1. For b, on the numerator, you simply get b, because negative 1 plus 2 is 1. Whereas the denominator here, we have a to the negative 2 times a squared, so the exponents add to 0, so they just cancel out. we have b squared times b to the negative 1. So add the exponents together to get b. We still have the exponent of n outside there. Okay, now from here, what we can do is, well, you can see the b's will just simply cancel out, right? Because just b each, it's gone. Now a to the negative 1, it's a negative exponent. So recall what we can do is we can simply move to the other side of the fraction, right? So it was on the top, now we move it to the bottom. We still have the n outside as the exponent. Finally, you could just distribute the n. So then you get 27 to the power of n over 16 to the power of n times a to the power of n. And that will be your final answer. Okay, so hopefully, somewhat complicated examples, but nothing new here. It's just applying the rules that we've learned in the past. Okay, so now we are going to, get into the lesson, the actual lesson today, rational exponents. So we have part 1 and part 2. Part 1 is simpler because you can see so rational exponents means the exponent is a fraction, or can be written as fraction, or it could be a decimal as long as it's terminating or repeating. Recall the definition of rational numbers in the previous lesson. So exponents bring rational numbers means, again, it could be a fraction or some kind of terminating or repeating decimals. The simplest one that we will see is 1 over n. So where the numerator is always 1, and we have some kind of denominator, some number, some positive numbers. It turns out that the denominator for the exponent is actually the index of the radical, okay, of this radical. So we can turn this radical into a power form easily, okay? So the base is a here, so that's just the radicand. In this case, the radicand is 2, so our base is actually 2. The index is 4, so that means the exponent is going to be 1 over 4, okay, because the index is the denominator, okay? Part B, something similar. We can turn this into power form. So recall, if there's no index, it means it's a 2, right? So this is going to be 2 to the power of 1/2 times this, we just did it, right? That's 2 to the power of 1/4. Now, because we're multiplying, so we are adding the exponents together. So 1/2 plus 1/4. Hopefully you remember how to add fractions. You need to have common denominators. 1 over 2 is the same thing as 2 over 4. Okay, so then you add them together. 2 out of 4 plus 1 out of 4 is 3/4. So that's how you change that into a power form. Okay, now we can also change these into radical forms, right? Going the other way around. So this is the base. Again, the base turned into the radicand. The numerator is 1, so that means we just need to look at the denominator because that will turn into the index. Okay, so there you go. Part B, similar. Again, this is the base. It's actually both a and b, so the radicand is going to be ab, and the index is going to be a 3, and that's it. Okay, so this is the simpler version of the rational exponents, where the rational exponent is 1 over something. Okay, however, obviously, the exponent, that fraction, is not always going to be 1 over something, right? It's going to be most likely some number divided by some number, okay? Not just 1 over something. In that case, it's actually the same, or similar, okay? N, that's the denominator, that is still the index, that doesn't change. Now, we do have a numerator that is not a 1, okay? It's not 1, so this numerator actually becomes the exponent of the radicand. Okay, so it's either written this way or sometimes it's written in this way. And I think this way is actually more useful in most cases. Okay, so just like in part 1, we keep the denominator as the index and radicand as a, and the numerator m is the exponent for the entire radical. Okay, so it could be expressed in either way, but I think this one is more user-friendly, I would say, right? Because you will see in a second. Okay, I'll show you some examples, then you'll see why this one is better. Okay, I shouldn't say better because both are the same, but I think this one is, when we evaluate, it'll be easier. Okay, So I'll show you this one here. 4 to the power of 1.5, we can change this into radical form. Okay, so 1.5, recall, is same thing as 3 over 2. Okay, so now we can turn this into radical form. The base is the radicand. Okay, the denominator is the index, which is 2. Usually you don't need to write it because it's a square root. Now, you can write the exponent with the 4, or you can write it as cube for the radical. Okay, so I'll show you why the second one is better. Okay, I will erase one of them later on. Okay, so if we do the first, if we write in the first form, right? In this case, what this is telling me to do is that I need to cube the 4 first, which means this is going to turn into, well, 4 cube is 4 times 4, 16, 16 times 4, 64. Okay, so I'm actually looking for the square root of 64, which is not too difficult to do, right? It's just 8. Okay, not a problem. But if you do it in the second form, what this form is telling us to do, well, it's telling us to take the square root of 4, right? The square root of a 4 is nice. That's easy to do. Square root of 4 is 2. So this turns into 2 cubed, which is 8. Okay, notice how in the first form we make the radicand bigger first before we take in the square root, whereas the second form we actually use the radical first, or so we square root first to make the number smaller and then cube it, right? So that's why second one is better, because you are making the number smaller first before you expand it, whereas the second one, this could get really, really big. And when it's really, really big, it sometimes it's not as easy to figure out the square root of that number, where square root of a smaller number is much easier to determine. Okay, so that's why I think this is more user-friendly. Okay, so I'm gonna erase those, and I'm just gonna write the second form. Okay, so the square root of 4 and then cube, that will give us 2 cube, which is 8. Okay, part B, same thing. So I guess we can just simply evaluate this. The fifth root of 32 is 2. Okay, and it might take you a while to recognize that, but once you do enough of these practice questions, you'll see it right away. Again, fifth root of 32 is a 2 because 2 times 2 times 2 times 2 times 2 is 32, right? So the fifth root of 32 is simply 2. And then now the 2 to the power 4 is 16. Okay, part C, I'll do this one and I'll let you try the next 3 here. This one, I see negative exponent, so I need to deal with that first. Remember, whenever you see negative exponent, all you need to do is change that into its reciprocal. So 16 becomes 1 out of 16, and now the exponent becomes positive. Okay, and now once we've done that, we can then turn this into the radical form, right? Radicand is 16 because that's the base. Index is a 4, and we're going to take the cube. Notice how this one, if you take the cube of 16, yeah, that's not so nice anymore, right? So we would rather do the fourth root first before we cube it. And the fourth root of 16 is going to be a 2. So that's going to be 1 over 2 cubed, which is 1 out of 8. Okay, so again, much easier if you take the root first, whether it's a square root, cube root, fourth root, whatever, okay? Make the number smaller first before you make it bigger. Much easier. Okay, so there are 3 questions for you to try. The third one might be might be a little bit challenging. I don't know, maybe not. You can't evaluate, so just simplify. Okay, so give it a try. Okay, I'm assuming you finished it. I'll go over these. Again, I see negative exponent, so I'm gonna flip the fraction. Don't worry about negative sign, just keep the negative sign there. Okay, and then we flip the fraction. So again, we flip 32 to 1 over 32 because the exponent is negative, not the coefficient. Okay, it's because the exponent is negative. Okay, the negative sign doesn't really do anything, we just keep it there. And now we're gonna turn this power into a radical form. So it's gonna be fifth root of 32 to the power of 4. Oops, 4, not 2. Okay. -1, we just did this question earlier. Fifth root of 32 is 2. 2 to the power of 4 is 16, so your answer is negative 1 out of 16. Part B, again, negative exponent, so I am going to flip this to 16 to the power of 2/3. I am going to change it into radical form. It's a cube root of 216 squared. And again, like I said, once you do enough, you'll know what cube root of 216 is. It is simply 6. So this is turned into 1 over 6 squared, which is 1 out of 36. Okay, because again, cube root of 216 is 6, because 6 times 6 times 6 is 216. If you cannot tell, okay, if you cannot tell, then you can do prime factorization, and I'll show you that. This is going to be 2 times 108, 2 times 54, 2 times 27, 9 times 3, 3 times 3. So you see that we will have 3 2's and 3 3's. So then this is same thing as 2 times 2 times 2 times 3 times 3 times 3 from previous lesson. Remember, when we're looking for cube root, we are grouping the same number. We're gonna group same 3 times, not 3 times. You're gonna circle the group of 3's. Okay, group of 3 same numbers. Okay, so this is 3 2's and this is 3 3's. And if you do that, you can actually take out 1 2 out. You take 1 3 out. And since there's nothing left, well, then there's no more radical, so it's just 6. Okay, so cube root, you're taking out, you're circling, you're putting groups of 3 of the same numbers. Square root, group of 2 of the same numbers. Fourth root, group of 4 of the same numbers. Okay, so it's cube root, so we 3 2's, 3 3's, take 1 out, 2 times 3, 6. And that's why it's 1 of 36 here. Okay, part C, it's not a number, so we can't actually evaluate. So what we can do is, we'll apply the exponent laws. We have exponent of 4 to the power of 4 over 3. So we simply multiply 4 with 4 over 3. And y, same thing for y, right? It's 1/2 times 4/3. And now we just need to multiply exponents. Recall 4 is something as 4 over 1, so multiply, you get 16 out of 3. And for y, you can actually reduce or multiply by reducing here. That's divided by 2, divide that by 2. So 1 times 2 is 2, 1 times 3 is 3. There you go. So that's how you simplify it. Okay. Hopefully they're not too difficult for you. If you need some help, again, let me know. Or watch the video again, at half speed. Okay. Simplify the radical. So same thing. In this case, we could move this too. Okay, we don't actually need to square it first. We know this is the same thing as that, right? We can actually move the exponent outside, and that's fine. Because if we do that, we can actually take the cube root of 27. It's quite easy. It's just a 3, right? Nice number. You'll always get a good number here, because I'm not going to ask you to use a calculator. So, everything is going to be nice. So 3 squared is 9. Okay. Part B, we can turn this into exponential form. So you can see that we can actually reduce this. So if we turn this into power, okay, this becomes b to the power of 3 over 9, right? Index goes to the denominator. Exponent is the numerator of your exponent here. 3 over 9 can be reduced to 1/3. So really, this is simply the cube root of b. Okay, just the cube root of b. Okay. 2 more examples I need to show you. Part A, this one is not too bad. Part B is the one that's kind of fun-ish to do. Okay, Part B is actually quite interesting. Okay, Part A, we have the same base, so we can turn this into exponential form or power form. This is 4 to the power of 1/3 over 4 to the power of 1/4. Right? The exponent is just 1, so we can just write as 1 over 3 and 1 over 4. Because we're dividing powers with the same base, we can simply subtract exponents. Okay, so again, to subtract exponents, you need to have common denominator, which is going to be 12 in this case. So 4 out of 12 minus 3 out of 12, your answer is 4 to the power of 1 over 12. as long as you keep the answer in as long as your exponent is positive in your final answer, you should be fine. Okay. Part B. Now here's the problem for part B. They don't have the same base. Right? One is 3, one is 27, one is a 9. They don't have the same base. There's nothing we can do about it. Wrong. Okay. Well, true that we don't have the same base. Then in that case, we can't do anything. However, we can actually turn them into the same base. Do you want to guess what it is? Okay. If you guess 3, good for you. If you didn't, well, that's okay. You haven't seen this before. It's not a big deal. Okay. We can actually turn everything into base 3. Okay, so this 3 to the power of x, we don't need to do anything. 27 can be rewritten as 3 cubed. And to the power of x is still to the power of x. 9 can be rewritten as 3 squared. Again, to the power of x, that's still the power of x. And now we can actually apply some exponent rules here. We have 3 cubed to the power of x. Again, that's exponents back to back, so we are just going to multiply the exponents together. So 3 to the power of 3x. Same thing in the denominator, that's going to be 3 to the power of 2x. Now they all have the same base. We can again apply more exponent rules. We are multiplying powers with the same base, so we can add exponents. X plus 3x is 4x. And we still have 3 to the power of 2x there. Now we are dividing powers with the same base, so now we're going to subtract exponents. 4x minus 2x is 2x. And there is your final answer. Okay, so part B, this one is slightly trickier, but not something that we cannot do. Okay, just what we need to do is to change everything to the same base because they didn't have the same base. Okay, so that's 1.2 rational exponents. You need to make sure you understand this lesson well, because next lesson it's gonna be crazy, or I shouldn't say crazy. Okay, I don't want to disencourage you or anything like that. It's going to be slightly more complicated examples. Okay, so make sure you understand this well, then you'll be fine for the next lesson. Okay, let me know if you have any questions, or again, watch the video again, do some practice questions. Good luck.